4, 3, 2, 1.
Good day, and welcome to another video lesson in Basic Calculus. Are you ready to learn another lesson today? Very well, but before we start, make sure that you have the following with you: your module, some sheets of paper, and a pen for your solutions. And most importantly, your study guide. As you watch the video, you will come across some items that need your response. And every time a numbered item appears, you may pause the video to write down your answers and solutions on your study guide. If you're ready, let's begin! Let's recall. Last time, we defined derivative using a mathematical expression. Can you write it down on your study guide? Yes! Last time, we defined derivative using this expression, where f of x is the given function, while this one refers to its value when evaluated at x is equal to x sub 0, while this one is its derivative at x is equal to x sub 0, while x sub 0 is the x-coordinate of our point of tangency. We also mentioned many times that derivative is a slope. My question is, slope of what? You're right if you answered it refers to the slope of the tangent line to the function at the point where x is equal to x sub 0, provided that such limit exists. Now, let's try to use this definition to compute the f prime of 1 of each of the following function. Compute the f prime of 1 of f of x equals 2x minus 3. Pause the video and try it on your own first. Our first step is to evaluate f of x at 1. Replacing x with 1, we obtain negative 1. After that, we will now plug in the known expressions and values to our formula. This expression will replace f of x. This will replace f of x sub 0. Our x sub 0 is 1. Hence, x is approaching 1. Simplifying our numerator, we will have 2x minus 2. Then, factorizing the numerator, this rational expression simplifies to the constant 2. Applying the limit of a constant, the limit of this expression is 2. Therefore, f prime of 1 is equal to 2. Try this! Show your solution on your study guide. To give you a hint, the value of f prime of 1 is 5. You can do it! Did you do it right? Well then, let's now proceed to our lesson proper. This time, we are going to define derivative in another way. To do that, let's study this illustration. Here, our tangent line to the green curve at point P is the orange line, while our secant line PQ is the red one. These are the coordinates of P. These are of Q. Later, we will let Q approach P and we will observe what happens to the change in x, which is this h value here. We also earmark the change in y, which is the difference between the y coordinates of P and Q. We're now letting Q move. Observe, One more time. Processing time. Question. What happens to H as Q approaches P? If we are gonna look closely, H seems to be disappearing. Or, we can simply say that H is approaching 0. In other words, Q approaches P implies H approaches 0. Take note of that. This time, we recall that slope is equal to the ratio between rise and run. Or, it is equal to change in y over change in x. Knowing that, what is the slope of our secant line PQ? Knowing that change in y is equal to the difference between these two, then change in x is equal to h, the slope of PQ is... Knowing that the tangent line at P is the limiting position of secant line PQ, what is the slope of the tangent line at P? The answer is... Like we noted earlier, Q approaches P implies H approaches 0. Finally, this is now the alternative definition of derivative, which we formally write this way. Solving time! Let us now use this definition to find the f prime of 2 of this given function. First, let's compute f of 2. Replacing x sub 0 with 2, we are going to have this expression, which means we have to evaluate the function at the quantity 2 plus h. And this is what we will get. Expanding some expressions and combining some terms, this will become, which simplifies to, by direct substitution, the value of this limit is equal to 1. Hence, f prime of 2 is 1. For our second example, let f of x be equal to sin x. Find f prime of 2 pi. Solving for f of 2 pi, sin of 2 pi is equal to 0. Plugging in the known values to our formula, we'll have... Now, in order to expand this expression, we are going to need an identity. In pre-calculus, you learned about sine of sum of two angles. What is our identity again? Here it is. Using this identity, our numerator becomes... And because sine 2 pi is equal to 0, we may remove this part. Meanwhile, cosine 2 pi is equal to negative 1. So this expression becomes negative sine h. Finally, this limit simplifies to... Does this ring any bell? If you can recall, this was one of the limits that we established during our second week. What is its value again? The answer is 1. So the value of f prime of 2 pi is equal to negative 1. Do you have any questions so far? Are there parts that were not clear to you? If there are, please write them down on your study guide. Knowledge and understanding check. Here is our alternative definition for derivative. What is the meaning of each encircled expression? Here is another example. Study the solution. Can you explain how this form became like this? At this point, you are now ready to try the practice exercises. You can find an answer key at the last page of your module. Use it wisely! So that's it! It is fun learning about derivatives, isn't it? I can't wait to see you again in another video lesson. Again, this has been Sir Aryan Molina, your basic calculus teacher. Thank you for watching and have a good day!